So we have seen LEDs are used to convert electrical signal to light, and LEDs work on spontaneous emission. So when electrons and holes recombine, you get light. But laser diode is going to be an advancement of LED, where and you know that only when we have direct band gap materials, we have this optical uh, creating a light that is possible only in direct band gap materials, which is possible in materials like gallium arsenide, indium phosphide, and other materials. But it is not possible in silicon and germanium because they have indirect band gap. So the in order to streamline the process of recombination in an effective way, so I'm going to have a special thing called cavity. So inside the cavity, I'm going to keep all these diode, and I'm going to have mirror on both sides to ensure that this generated photons are reflected back and forth between the mirror. And at one particular point, when the loss becomes equal to the gain, the photons will be coming out in a coherent manner. Okay, it is just a conventional PN junction diode only, but I'm going to keep this inside a cavity, and I'm going to control the population inversion by using a current injection. So you know that you have to create population inversion in laser diodes. Okay, so I'm going to form this cavity from a high fidelity reflective cleaved phase from a perpendicular to the junction plane. The typical characteristics of laser diode are shown here, and in diode the opposite ends of junction are polished to get mirror like surface. So see here, it's a conventional PN junction, but it is placed inside the cavity, and here on both sides I'm going to have mirrors, highly polished mirrors. Okay, and I'm going to keep this entire thing inside the cavity, and when I apply a proper voltage, so until the losses are going to be balanced by the medium, the current will be very less. And at one point when the loss is going to be equal to gain, the current is going to increase proportional to the applied voltage, and that current where it starts increasing is called as threshold current, I. Okay, and one difference between LED and laser: in a laser, the light beams are coherent. Coherent means all the photons will be moving with the same velocity in phase. But LED, the light coming out of LED will have random velocity of each photon. All photons will be moving with a different velocity in LED, but they will all move with the same velocity in laser. That's why the laser beams are very sharp and intense, and they say that when you focus the laser beam to a particular object, it starts burning because the photons are highly coherent. Coherent, not they are united in traveling. They all travel with the same velocity. So when the free electrons recombine with holes, photons are emitted. This operation you know, and these photons will reflect back and forth between the mirrors. See, there is no way for the photons to come out because both the ends I have mirrors, and light when it falls on a mirror it gets reflected, right? So these photons will travel through the entire device, and they will get reflected between the two mirrors back and forth. So this region between the mirrored ends acts like a cavity. It filters the light and purifies its color. So as the photons are going to travel back and forth, it is just like how you have avalanche breakdown. So they produce an avalanche effect where all photons will have the same phase. So the whatever photon is going to be produced, it will join the already running photons which are running between back and forth. So this is going to be creating an avalanche effect. And out of the two mirrors, one mirror is semi-transparent. Semi-transparent means it can the photons can escape through the semi-transparent mirror. So once the required amount of photons are going to be formed, the fine beam of photons are going to emerge out of the one of the mirror. And see the important property: all the photons will have the same frequency phase, and hence they are called as coherent. It's very simple. You have a cavity. Inside the cavity, you have P-N junction diode, and on both sides of the cavity, you are going to have highly polished mirrors. As you apply voltage, electrons and holes recombine to produce photons. These photons don't know how to come out. So they travel back and forth between the mirrors, hitting them. Once they form the avalanche effect and they are sure that required amount of photons are collected. So they start coming out of one of the mirror, which is semi-transparent, giving rise to highly intense coherent beam of light. Okay, so that light will have the photons inside the light will have the same frequency, same phase. So when frequency and phase are same, you use a beautiful term called as coherent to name the photons. So those photons are going to be coherent. So when you can see from the power characteristics, so until a particular point, the current is very minimum, and after that, current is going to increase, power is going to increase, right? So the current at which the power is going to increase is called as threshold current. The below threshold, I will be having spontaneous emission. After threshold, I will be having stimulated emission. So stimulated emission is the property of your laser diode. So below threshold, I'll have spontaneous emission just like an LED. After threshold, I'll be having stimulated emission, which is going to be the unique characteristics of laser. So at the limiting current density, stimulated emission happens and the radiation will increase linearly with the drive current. So radiation means the amount of photons, and power is proportional to the number of photons. So as the current is going to increase, the power is going to increase proportionately. So that is going to be seen in the VI characteristics, which we have seen just now. So any queries on laser diode? It is we are not studying the laser diode in depth here. We are just studying what is the operating principle only, because that is required in that is like that alone is required for you in this subject perspective. So you need not study about in-depth working or functioning of lasers. You have to understand how the recombination is going to happen, how the mirrors are going to produce an avalanche effect, and how light is going to come out from the laser diode. So that is going to be our that if you learn, it is enough for the subject perspective. Additional learning, you can refer to any decent optical communication book for the functioning on the laser, but that will be too advanced for you. So just for the second semester, you are just required to know about the basics of laser. So this explanation and these diagrams would do for laser